There's a whole lot of room squeezed into a gas cylinder. Take this one, for instance, full of hydrogen, 260 cubic feet of it. That's enough to fill a storage space. And that's, of course, why gas cylinders exist, to squeeze down the space needed to more efficiently store gases. Now, obviously, this gas is under a lot of pressure, and that can become dangerous. Say a gas cylinder is full of compressed hydrogen, and a small leak develops at the valve. The high pressure forces out the gas, pushing it great distances. It flows over bench tops, passes electrical devices, and maybe finds a source of ignition, a spark or open flame. There are three things going on here. We have a leak in the system, we have the wide dispersal of the gas caused by high pressure, and finally the specific hazards of the involved substance itself. In this case, it's flammability. This is just one scenario, but it does demonstrate why we should pay attention to the safe use of gas cylinders.
There are four basic ways to store pressurized gases. The first is called standard compression, where substances such as oxygen, hydrogen, and nitrogen are squeezed into a cylinder, but kept in their gas form. The second way to store gas is as a liquid. This only works for gases that condense under ordinary temperatures, or at pressures between 25 and 2,500 pounds per square inch gauge. Two examples are carbon dioxide and propane. The third storage method is to dissolve a gas in a solvent. Acetylene, the only substance dealt with in this manner, is unstable in pure form and must be dissolved for safe storage. The fourth method is to compress a gas into a cryogenic liquid. This only works for substances with boiling points below negative 238 degrees Fahrenheit. Some examples: nitrogen, oxygen, and argon. It is important that we know how each of the substances we work with behaves when compressed through these methods. And we must be aware of the safety precautions necessary to successfully handle each gas. This includes personal protective equipment. For instance, work with cryogenic materials demands the use of goggles, a face shield, and impervious gloves. Extremely low temperatures can cause severe burns to the skin. Prolonged exposure can cause frostbite. These low temperatures can make valve washers brittle so that they break away and cause leaks. Steel may fail when subjected to impact. This is particularly unfortunate because cryogenic liquids produce huge volumes of gas when they vaporize. If the gas is oxygen, it can quickly enrich the atmosphere, increasing the chances for a fire or explosion. A leak of some other gas may push breathable air out of the room, leading to asphyxiation.
Even a small leak can produce an atmospheric hazard. And here's a second scenario. If a cylinder fell, severely damaging its valve, the rapid release of gases could turn the cylinder into a rocket. And we've all heard those stories before. So we can see why it's so important to handle and store cylinders with care.
Cool, dry, well-ventilated spaces are best for storage. Secure cylinders upright and strap them into place to prevent falling or bumping. Safety caps must remain on until cylinders are hooked up to systems. Keep containers out of direct sunlight. Rising temperatures increase internal pressures. Separate flammable gases from oxidizers by at least 20 feet or by a wall. Any mixture of leaking gases could be dangerous. Keep flammables and oxidizers separated from live electrical equipment and other potential sparking sources. Smoking is never permitted in cylinder storage areas. Don't tamper with the cylinder's identifying labels or stencils. These are the only ways to safely tell what gases are inside. Cylinder paint color should never be used as an indicator. Cylinders containing corrosive gases should not be stored for more than 6 months. The same goes for substances which may polymerize. Containers of ethylene oxide, unless refrigerated, should never be stored for more than 3 months. As we said, the careful handling of cylinders is important. Never drag them across the floor. This can damage the walls of the container or its valve. Hand rolling is also a bad idea. The container can slip and fall, ushering in all sorts of problems. Moving cylinders with a hand truck is always the safest course. Four-wheeled versions are the most stable. Safety caps must always be in place whenever a cylinder is being transported, even over a small distance. Caps protect the cylinder's valve in the event of a fall.
If a falling incident does occur, don't try to catch the cylinder. This may seem like strange advice when you consider the potential damage of the broken valve and rocket scenario, but more people are injured while trying to catch heavy falling cylinders than by the rockets.
The best plan is to leave the safety cap on, handle cylinders with care, and always wear your safety shoes. Use service elevators or dumbwaiters to deliver cylinders to other floors. Riding with a cylinder is not recommended. An elevator is a tight space, and a leaking cylinder can quickly foul the air, setting a trap for you. Instead, walk up the stairs to meet the cylinder when it arrives, or have someone else in position to accept the cargo. Labs must be equipped with a secure method for keeping cylinders upright. A rack system is the only way to go. Clamps are used to keep the cylinders in place. A chain draped across a group of cylinders will not do. It is too easy for a cylinder to fall over and slip out underneath. The strongest clamps are anchored to the lab bench at 2 points. Make sure the fit is tight. Clamps with thumb screws are the easiest to snug up. The idea, of course, is to keep cylinders from falling or knocking into one another. Any physical stress can lead to leaks or ruptures. Some states have more rigorous requirements than others for the securing of cylinders. Ask your supervisor about the laws in your area. And here's a special note. If at any time you detect a gas leak, immediately report it to both your supervisor and the equipment supplier. Remove the cylinder from service. This goes for rusty or corroded cylinders as well.
Once the cylinder's in place, it is finally safe to unscrew the cap. Never force it off with a screwdriver or bar. That tactic could accidentally open or damage the valve.
Placing a cylinder into a gas delivery system will require the investigation of a few other elements. The first is the regulator. This device is crucial to a gas delivery system. As we know, cylinders are filled to extreme pressures. The task of the regulator is to reduce the delivery pressure to safe, usable levels. The second device is the CGA fitting. This should be permanently attached to the regulator. It connects to the cylinder valve to allow for the withdrawing of gases. There are specific fittings designed for specific gases. Some CGAs are larger than others. Some have washers. Some have notches. Threads may be right or left-handed. CGAs vary depending on the type of gas, so hooking up the wrong cylinder to a system becomes very hard to do. As we know, mistakes in this area can be critical. For instance, a flammable gas placed by error into a system near an ignition source could cause an explosion. So never attempt to force a CGA onto a valve. If it isn't fitting correctly, it's for a reason. A third system element is the cylinder's pressure relief device. These are installed to prevent rupture and violent pressure release if the cylinder is exposed to extreme heat. In case of fire, for instance, the relief device will open and allow for a controlled release of the material. If the gas is flammable, this will unfortunately add fuel to the fire. However, this is still preferable to the cylinder exploding. There are no relief devices on cylinders used to store toxic or poisonous substances. Any escape of these gases is considered too dangerous to risk. Another device, a flame arrestor, can also be used with flammable gas cylinders. These help prevent flashback. Once you've assembled your system and have it up and running, you should check fittings and valves for leaks. Cover surfaces with a diluted soap solution. Any sign of bubbles will betray a leak. Adjustments are generally simple. All it may take to fix a leaky valve, for example, is half a turn with a wrench. If you're at work and suspect a leak, Alert other employees in the area. Unplug potential sources of ignition when flammables are involved. Never enter a leak area without a self-contained breathing apparatus. And never put one of those on unless you've been fully trained to do so. Backup personnel must assist you. The size of the leak and the material involved may call for an evacuation of the area.
Remember, if a problem does occur, you should take action according to your facility's emergency plan and the material safety data sheets for the substances involved. Using gas cylinders becomes complicated only when you don't do your homework.
Know the properties and hazards of the chemicals you work with. Know how to safely store and transport cylinders. Be aware of the ways in which regulators, CGAs, and pressure relief devices operate.
And finally, remember that most incidents should never occur. Preparation and foresight are the keys.